Hi guys, welcome to Science in 5.
The Big Four.
In this video, we're going to discuss
the Big Four. Yeah. The Big Four. Yeah.
Right. Gotta kind of catch it.
The Big Four. Oh, the Big Four. The Big Four. Yeah.
Oh,
Good.
we're losing sight of the objective. Okay, thank you. All right. In this video, we're going to discuss the Big Four, the four equations of motion. I call them the Big Four. Sounds catchy, eh? Yeah. So we're going to discuss the four equations of motion, skills and tips on how to handle questions involving the Big Four. Let's get to it. Don't mind him. He'll be fine. In this video, we're going to discuss the Big Four equations of motion. The Big Four equations of motion are only applicable when an object moves at a constant acceleration. This means that the value of the acceleration is the same. Let's look at this example. We have this truck starting at a velocity of 0, and the truck begins to increase its velocity steadily in the eastern direction. So the velocity is increasing steadily. Let's say every second we're adding 2. So from 0 we go to 2. The next second we add another 2, we get 4. The next second we add another 2, we get 6. The next second we get another 2, we get 8. So the velocity is changing at a constant rate. We know that the change in velocity is simply acceleration. So if we're to plot an acceleration time graph for this truck, we will discover that the acceleration is at a set value. Okay, what will be that set value? The acceleration is not changing. Okay, that set value is 2. So the acceleration is 2 meters per square second. This means that the velocity of this truck was changing by 2 meters per second every second. If we were to plot a velocity time graph, we would also see that the velocity of this truck was changing at a constant rate. What is the constant rate? Well, the constant rate is 2 meters per second again. Well, we know that the gradient of a velocity time graph, if you were to measure this gradient, it would give you what? Well, it will basically give you velocity over time. This will give you acceleration. Okay, this will basically give you an acceleration value. So, for example, if I use this as my point, I would discover that the velocity is 4 after 2 seconds. So 4 divided by 2 gives me the same acceleration value of 2. So, once the acceleration is constant, in other words, the velocity is changing by the same amount every second, we can use the Big Four equations of motion. Okay. Now, the Big Four equations of motion, they're easy to remember, guys. You've got to remember them. You've got to practice writing them down. Don't fall into the trap of saying, I don't need to know them. They're formulas. They can be in a formula sheet, so I don't need to worry about them. The reality is you actually need to worry about them a lot. Okay. 2 of them start with VF, but one of them is actually a VF squared. And then the other 2 start with delta x. So 2 VF, 2 delta x. Okay. So the first one says VF is VI plus A delta t. The second one says VF squared is VI squared plus 2A delta x. The third one says delta x is VF plus VI over delta t. And the last one says delta x is VI delta t plus half A delta t squared. Now, what are these symbols representing? Well, VF basically means the final velocity. So it's almost like velocity final. VI, velocity initial velocity. So another thing about physics, motion and forces is the reference point is always important. when did you see the initial velocity? When is the final velocity? So a system of referencing is very important. Okay, the A is always acceleration. Okay, and then the delta x just is displacement. It can also be changed to delta y if you are looking at vertical motion. Instead of saying delta x, movement along the x, you can say delta y, and the delta t is the time interval. Okay, so there are 5 variables, as you can see: 1, 2, 3, 4, and 5 that are involved in these big 4 equations of motion. And like I said, you've got to practice, find a way of getting around knowing them. Probably you see physics guys seem to like not answer questions a lot with this big 4, probably because they know the formulas. They don't even have to refer to the formula sheet. Okay. Now, there's another version of the big 4 equation. Instead of saying VF equals VI plus A delta T, we just use different symbols. We can say V equals U plus AT. Now, the different symbol is that instead of saying VF, we can say V. Instead of saying velocity final, you can use the symbol V to represent VF. Instead of saying VI, you can use the symbol U. Okay, so it's the same equation, but we're just going to be using different symbols. Okay, now note there, instead of saying delta x for displacement, you can use the symbol S for displacement. Okay, that's another form of the big 4 equations. Very common. There's nothing wrong with using the alternative form of the big 4, okay? But I think the delta t and the delta, for me, just sounds a little bit technical, like delta x, delta t. Yeah, it just sounds technical. So for me, it's just an issue of preference, but there's nothing absolutely wrong with using those formulas in green. They're the alternative form of the big 4. So that is the introduction to the big 4. Now we're beginning to know what the big 4 are. Let's practice writing them down. Find out what those, make sure you know what each of those variables in the formula mean, and you're good to go. In the next video, we're going to develop the idea of the big 4. Where do the big 4 come from, and how do we use them? Stay tuned. Remember, Science in 5 will keep science alive.